Guys, this is my real world static analysis. My name is Maximilian Rodriguez. So we have our static object. The static object I chose was a basic parking lot light pole. The object's components, it has a small hanging light fixture. The light pole has a fixed support assumed to be straight down into concrete, and the loads. We're going to be comparing the support reactions with and without wind loads on the pole. So the static object in detail. We can assume the material of the basic light pole is hollow steel based off the sound and the manufacturer's website. The dimensions of the pole is 7.62 meters tall, and it has a 0.1684 meter wide base, square all the way up to the top. The support. The support is a fixed support into a concrete base assumed due to a cover hiding any bolts or any other supports, so we can just simplify this to a fixed straight support into the concrete. The weight of the pole based on the manufacturer's website has a weight of 210 pounds or 1,378 newtons. And then we go on to the light fixture assumptions. So the light fixture's material can be assumed to be aluminum based off another manufacturer's website. The dimensions of the pole is 0.65278 meters in length from the pole to the end of the light fixture, and the weight can be assumed to be around 61.83 newtons. This is all based off the manufacturer's websites rather than assuming what the pole is made of. We can assume it is close to or similar to the light pole on the manufacturer's website. So we have the static analysis under normal conditions. We can see here the free body diagram of the light pole, and we have the knowns and unknowns. We can see here weight 1 and weight 2 is the weight of the pole and the light fixture going down on the z-axis. So this is our knowns. So we have weight 1 and weight 2 as our knowns, and then we see the support reactions at point A is our unknowns. So we would have to solve for these forces and moments that are keeping the light pole in static equilibrium. So solving for the static 3D equations of equilibrium, we can set everything else to 0. And then we see here, we solve for x, and that would be equal to 0 because there's no forces acting in the x direction. We can solve for y, and y would be 0 because there's no forces acting in the y direction at the moment. But z does have a support reaction of 1,439 newtons due to the light pole weight in the z-axis. So the light pole and the light fixture combined would give us that support reaction. Then we begin solving for the moment reaction at point A, and we see that mx, the moment of x, produces a 20.1807 newton per meter reaction based off the light pole fixture wanting to rotate it around the x-axis due to its weight. We see that my doesn't produce any reaction because there's nothing forcing it to want to rotate around the y-axis, and z does not have any support reaction due to the same concept. Given the wind loads, so the wind loads we can solve for based off the total surface area of the pole. This can be assumed to be around 5.01 meters, and we assume the wind will hit around half of this at a single time, which given is 2.74 meters. Given the air density and the highest gust recorded in El Paso of around 84 miles per hour or 37 meters per second, we can put it into this equation and solve for the wind load in newtons, the force on the light pole. So we plug it into the equation and we find that the wind load is 2,135 newtons on the surface of the pole. So we see here the static equilibrium under wind loading conditions. So in the free body diagram, we now see that we have the knowns weight 1, weight 2, but we also have the knowns of the support of the wind loads on the pole. So we can split it up between the wind loads on the pole and the pole's fixture. And then we still have the unknowns, so the new support reactions based off these new wind loads. So we solve for the static 3D equations of equilibrium. Again, we set the forces equal to 0 and we solve. So in the x direction, we can see clearly that there is the wind load acting in the x direction. So we have a support reaction of 2,135 newtons. And then in the y direction, there is 0 because there's no forces acting in that direction. And then in the z direction, we have the same support reaction based off the weight of the pole and its light fixture moving down in the z direction. Then we can solve for the moment reaction in the xyz around point A. So then we see that a moment is created in the x direction, again because of the light fixture, weight wanting the poles will rotate around the x-axis, and then we have the y, which is new and way bigger than before due to the wind loads acting in the x direction, wanting the pole to rotate around the y-axis. So this causes a moment of 8,964 newtons per meter. And then solving for the z, there is no z moment due to no forces acting in the z direction. So the final analysis. The light pole will undergo bigger reaction forces under wind load conditions, of course, due to the wind loads. So the light pole will stay rigid and static under wind load conditions, and we can assume this based off tensile strength versus stress. So if assuming our light pole is made out of steel, the tensile strength of steel is 65,000 psi. And then we can solve for the stress on this light pole based off the force over the area of the light pole the force is acting on. So we can assume the force is 7,167 over 2.7 meters squared of area, and then this gives us a small psi, not even comparing to the 65,000 psi the steel would be able to handle. So we can assume in the end the light pole will stay rigid and static under the wind load conditions due to the load of the pole having a lower psi stress than the tensile strength of the light pole material, steel. This is all based off assumption, and it may not be fully correct due to the assumptions we made. And if we had a different material or a different fixed support with, instead of one straight pole into the concrete, we had bolts and we had a different support reaction there or moment acting there. And this is all based off assumption, and there's limits to this, but this is the results we got. My name is Maximilian Rodriguez, and thank you.